Welcome to this video on AutoSys AWS Lambda solution. In this video, we will explain the AWS Lambda integration with AutoSys and its benefits for the AutoSys user community. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the design and invocation of a Lambda function in the AWS environment. Finally, we'll run through a demo. AWS Lambda is a serverless compute service that revolutionizes the way code is executed in response to events from various applications. Say goodbye to the hassle of setting up and managing servers. Let's dive into a real-world example to better understand AWS Lambda in action. The image shows a photograph being captured as the first step. You can use the AutoSys Amazon S3 integration to upload files and monitor file creation in an Amazon S3 bucket. When a file is detected, the AutoSys S3 job can trigger a downstream AutoSys Lambda job to invoke AWS Lambda function. This AWS Lambda function is specifically designed for image resizing. The Lambda function takes the original photograph and generates resized versions optimized for various platforms such as web, mobile, and tablet. The resized images are now available in different formats and sizes, ready to be utilized in a lot of ways. The AutoSys integration with AWS Lambda allows you to trigger and control AWS Lambda job executions directly from within AutoSys. AutoSys plays a central role in orchestrating operations across multiple environments, including the cloud, and synchronizing these processes with other non-cloud operations. Integrating AWS Lambda allows us to centrally configure process automation in AutoSys. These AWS Lambda processes seamlessly sync with different environments supported by AutoSys, such as applications and databases. This integration allows you to effortlessly execute AWS Lambda jobs through AutoSys. By leveraging AutoSys' advanced capabilities, you can accelerate your digital transformation efforts with greater success. Simply define your AWS Lambda jobs and let AutoSys manage the scheduling of these workflows seamlessly. AutoSys lets us build configurations with intuitive interfaces and monitor them through simple dashboard tools specifically designed for operational use. Statuses are clearly indicated, and accessing logs is as simple as clicking a button. From an operations perspective, AutoSys greatly simplifies the configuration and orchestration of Lambda jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workloads. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workloads. The job submission sequence is fairly simple because all job definition properties are stored in the AutoSys plain old Java, or POJO job. All the target system properties, including the endpoint invoke job REST API, access key secret, region, other parameters, are defined in the J2EE parameters. These parameters may vary depending on the authentication method used. Let's look at the sequence of execution. We start with the three main components: the AutoSys scheduler, the system agent, and the AWS Lambda server. The AutoSys scheduler submits the POJO job to the system agent. The system agent acknowledges the job from the scheduler and initiates communication with the AWS Lambda server. Authentication is then initiated, with the system agent posting access key-based authentication, EC2 profile instance, or ADFS external provider, SAML authentication, depending on the specifications provided in the authentication J2EE properties. In this video, we are using access key-based authentication, which uses a combination of an access key and an access key secret. Once authenticated, the agent submits the job to the AWS Lambda server as a POST request. The AWS Lambda server identifies the matching job and executes it. The job execution returns a JSON response which contains the execution details. Subsequently, upon the job's execution, the job status in AutoSys is updated accordingly to either canceled, succeeded, or failed. Let's look at how to deploy the integration. First, ensure the Application Services plugin is installed as a prerequisite. The Application Services plugin and Pojo extension have the CFG extension. In older agent versions, you might encounter a PAK file instead. Next, download the plugin extension package from the marketplace. This package contains all the necessary elements. Unzip the package and extract the content into a temporary folder. Navigate to System Agent Install Directory. Next, we must stop the system agent with the cyb agent-s command. Install the plugin extension with the command plugin installer system agent install directory/path to CFG file. Now, restart the system agent with the cyb agent-a command. Remember, this integration uses AWS Lambda Public REST API. In our demo, we will create an AWS Lambda Pojo job in AutoSys. First, let's establish communication with the AWS Lambda server. After communication is established, we can execute the job. Let's dive into the world of applications and job execution within the AWS Lambda environment. Let's start with the demo. Let's explore how AWS Lambda functions are set up, triggered, and edited within the AWS console. Here in the AWS Lambda console, you can see a list of functions available in the environment. Let's dive deeper into one specific function. This is the Lambda function called Lambda with Perm. The Add Trigger button allows you to add new triggers that invoke the function. These triggers can be events like HTTP requests, file uploads, or database changes. The tabs for configuration, monitoring, and more provide you with the ability to configure various settings related to the function. With the code editor, you can see the Python code for the Lambda with Perm function. It takes two parameters, event and context. The function logs a message to indicate that it has started. It then checks if an ID is present in the event object, and based on its existence, it returns different messages. Now, let's proceed to log in to AutoSys for the next step in our demo. Click the Quick View tab to view the job definition. Select the job to open the job definition. The job employs access key-based authentication for the demo. When the job is open, click the Quick Edit button to view the required parameter. The first step in executing a job is to select the machine on which the job is to be executed. The first parameter is the class name, which is AWS Lambda, and the second is the method name, which is an invoke Lambda job. Now look at the gateway parameters. Understanding these gateway parameters is an essential part of the process. The endpoint parameter indicates where the AWS Lambda service resides. Then the access key and the access key secret. Access key is the identifier and the access key secret is the corresponding secret password. The region parameter indicates the geographical region where AWS Lambda computing jobs will be executed. The payload parameter specifies any additional JSON data that should be included with the request. If there is no additional data, this parameter can be left blank. The function name parameter specifies the name of the AWS Lambda function to execute. The invocation parameter determines how the function is invoked. The log type parameter lets you specify the logging type for the function's execution. The client context parameter lets you include additional encoded data in a specific format. The qualifier parameter specifies a version or alias when invoking the AWS Lambda function. Lastly, the log level parameter specifies the level of detail for logging information related to job execution within AWS Lambda. Once you have specified all the J2EE and other parameters, click Commit and close it. That completes the job definition. Let's now start the job. Once all the parameters are defined, select Start the job and click Go. To confirm the job execution, click Yes when prompted. Notice the current run number for the job is 3653. Upon refreshing, a new execution is triggered, increasing the run number from 3653 to 3658. A status of success indicates that the last execution was completed successfully. To access the spool files, simply scroll down on the user interface until you locate the spool files section. From there, select the desired file and click on the Go button. You will then be prompted to specify the number of lines you wish to display. Reports for all statuses are accessible for further investigation or utilization. As we examine the successful job, we can see that all parameters passed by the user, such as job details and authentication parameters, are displayed. Now, let's take a quick look at the job status in the AWS Lambda instance. As you can see, this was the job that we triggered and it is completed. And that's a wrap for the demo on how AutoSys can integrate with an AWS Lambda to execute various jobs. Thank you for watching this video.